Okay, there's going to be pressure on routing. IPv4 address price escalation and the consequential v4, v6 NAT PTs will put serious new pressure on routing. If it takes a $10 million router to deal with 2 million routes, and the churn that goes with them, the route churn's what's expensive, it's not the RAM to hold the routes, then 96% of ISPs die. And enterprises cannot be multiple homed. Right? Because an enterprise class router has to be able to handle lots of routes. Okay? And so all routers from enterprise bordered ISP core need to handle 2 megaroutes. Don't accept hacks around this problem. Hacks are things like some folk at a large vendor are saying, well, we have this hacked protocol that means you will route to some place that is big enough, because that you want to avoid, because then they own you. Okay? So that's to be avoided. Forwarding is behind. Because lack of market, it'll be 5 years before the router vendors can really take high-speed line rate. Some are not even spinning the ASICs, as I said, and it needs to be all vendors, not just one vendor. The fact that Juniper's better than Cisco doesn't help me, because if multiple vendors don't do it, the one vendor who does owns me. So we're not interested in we can do it and they can't. We need good v6 test equipment. We need to stop adding features so that we can deploy it. we need it. We have operators saying, they're talking about doing this, they're talking about doing that, I've got to wait. Don't. Freeze the damn thing and give us a chance to deploy it. There's another bad example. Okay, I'm going to go through an example here. The end-to-end principle is very desirable. v6 is incompatible. During transition, there will be NAT.PT, the protocol translator. Get over it. But we need to make it so that they can fade away. NAT.PT at the edge for sites that need to run v6 internally because they can't afford v4 space, but need to present v4 and v6 to the world. Okay? So the ITF needs to go back and standardize NAT.PT. In July of last year, the ITF published an RFC saying, take NAT.PT and make it historic. We don't want to talk about it. This should tell you a lot more about the ITF's level of operational clue and how much they care about religion as opposed to deployability. Very tragic. They are fixing it, though. The chair of the ITF and the appropriate people who wear funny-colored badges who need to do these things have reversed, and they say they're going to fix it. Of course, it takes the ITF much less time than it takes the ITU to change something, so I expect something within the next decade. Windows XP is cute. It can move packets over IPv6, but it does not do DNS over v6. It only does it over v4. So this means I can put a Windows XP system on a v6 network, and if you're willing to do everything with IP addresses instead of names, that's fine. I think some of you will see this as not good for your business, though. Okay? That's a bug. Microsoft reaction by Vista. So the LAN, the hack is you put, you know what RFC 1918 space is? It's those funny addresses that aren't routed globally on your LAN so that Windows XP can get to DNS, but it doesn't exit. So you get an IP6 and an IP4 address, but you only use the IPv6 for transport. NAT.PT and security, yeah. So on a pure v6 network, if I get an A record, in other words, an IPv4 address, what do I do with it? Cry, because it's not usable. I need a v6 address. So in this situation, in a v6 only network, while we're still transitioning, and i.e. for the next 20 years, the DNS cache has a hack, which we call TOTD, which, oh my God, I forget what it means, which takes an A record embeds it within a hacked v6 address, synthesizes a quad A record, a v6 address record, and returns that to you. Then the nic.at knows the same hacked prefix and decodes it. This is worth showing you a picture. Here's the client. They says, give me google.com. It goes to its cache server. This guy asks the real DNS, give me google.com. It gets back a v4 address. He says, I can't hand this guy a v4 address. He only has v6 transport. So it embeds it in a fake v6 prefix, hands it to this guy. This guy goes over v6 transport to the exit. The exit says, oh, I know that. Changes it back to the v4 address, goes to the real Google, gets the response, inverts it, and hands it to him. That's what I mean by no simple transition mechanisms. I hit the wrong button again. Just at the beginning of this week, the North American network operators met 500 odd, about 550, almost 600 people in San Jose, California. We had a 45 megabit exit to the net. We had wireless with multiple IDs on it. And we ran multiple networks, one of them dual stack, one of them v6 only, one of them hacked to support XP. This was the first experiment to see, for operators to see what it will take to make customers able to run v6. The network kind of looked like this. This is the hacked XP network. So there's a local v4 address with no default exit route, a global v6 address. XP users could bond to this one. Here's that .d DNS hack, a v6 only router, a true v6 network, and nic.at to the exit. Unix, Mac, Vista, etc. should all be very happy here. So here's the SSID. Okay, and then 1 hour or two on Tuesday, we took the v4 networks away. Okay, so the people had 2 days to figure out how to use it and then see what happened. We gathered statistics and we gave a report on Wednesday. What we learned: 3/4 of the users said they could get on net, but I think it was more like half. So we have 1/4 of the membership that are liars. Actually, I think they use things like cell phones and EVDO, etc. Every component except the Unixes had bugs, had failures. I think it's wonderful that given all that, it still worked pretty well. But the prize failure I just have to mention is Mac OS, which when you entered a DNS server address, you know, the IPv6 address in hexadecimal, if you had a capital A in it, that capital A got dropped. Not capital B's, not lowercase a's, just capital A's. Do not shout at the DNS. We hope the vendors are now working to fix. All of them were there and all of them were going and calling home. This is what the traffic looked like. Okay? So, as you can see, on the order of half actually succeeded. This was a bug in the nic.at gateway, so the nic.at was insufficient to the task of 550 users. It was a little Linux box. There are ongoing experiments, similar but not identical. Apricot APNIC, which is where I fly next. The IETF a couple of weeks later, AFNOG, which is the African Network Operators Meeting, LACNIC, ICANN, etc. So, in summary, the IETF, nic.at please, no more features. Router vendors, dual stack on the fast path and hold lots of routes. And the ISPs, dual stack to the customer edge. And governments, please incent, don't regulate. You can help. There's a wiki. You can read it, you can add to it. There it is, the 5th cluster of civiltongue.net. Okay, if you need to get this information or anything, just write to me. You can edit the wiki, you can add to it. There's stories, instructions, documentation, etc., etc., etc. This is done and supported mostly by ISOC. Of course, my employer in Initiative Japan, and lots of people who helped. And that's the story. Question?